Supply chains are failing, raw materials are getting scarce, manufacturing costs are skyrocketing, but Ottoman blacksmiths operated for centuries without depending on external supply, turning waste into wealth and scrap into superior tools. As our industrial systems prove increasingly fragile, maybe it's time to learn from smiths who never experienced a supply shortage because they never depended on systems they couldn't control. Their workshops were anywhere metal existed. What you're about to discover isn't just metalworking history. These are proven techniques that kept Ottoman armies equipped across 3 continents, using nothing but salvaged materials and knowledge perfected over generations. If you're fascinated by superior technology created from nothing but skill and recycled materials, hit that subscribe button because we're diving into metallurgy wisdom that modern engineers desperately need to rediscover. When Ottoman armies moved across continents, they carried complete workshops that could transform any location into a sophisticated production facility. Modern military logistics experts study these systems because they achieved complete manufacturing independence in hostile territory. Ottoman smiths designed modular furnaces that disassembled into components small enough for pack animals, then reassembled in under 4 hours to reach temperatures exceeding 2,000 degrees Fahrenheit. These weren't crude field forges, they were precision manufacturing systems capable of producing weapons matching anything made in permanent workshops. Every Ottoman blacksmith was trained in resource identification that turned battlefield debris into raw materials. They could evaluate metal quality by sight and sound, determine carbon content using simple tests, and assess any scrap metal's potential. Broken weapons became steel stock, damaged armor provided iron, and even horseshoes transformed into high-quality blade material. The workshop system scaled from individual smiths to industrial production. Large campaigns featured coordinated forge networks where multiple smiths specialized in different components, creating assembly lines that equipped entire regiments, using nothing but scrap materials and systematic production methods. This manufacturing flexibility made Ottoman forces extraordinarily resilient. They could operate indefinitely using local metal resources, while European armies relied on distant suppliers. When enemies attempted trade blockades, Ottoman forces actually benefited by recycling enemy equipment into superior replacements. If you think turning battlefield trash into superior weapons sounds impossible, wait until you see the specific techniques they used. But first, smash that like button if you're amazed by this level of engineering self-reliance. Your average person sees rusty junk. Ottoman blacksmiths saw raw materials with specific properties and manufacturing potential. They developed identification skills that assessed any metal's suitability using traditional testing methods that worked anywhere. Visual assessment revealed metal composition through color, texture, and corrosion patterns. Sound testing provided information about internal structure. Different metals produced distinct tones when struck, revealing carbon content and hidden flaws. Heat testing showed optimal forging temperatures and identified problematic impurities through spark patterns and color changes. But identification was just the beginning. Metal preparation transformed random salvage into manufacturing-ready stock through systematic processing that removed impurities and standardized composition. Ottoman smiths understood which metals could be combined effectively and which processing methods produced optimal results. The real innovation was composite construction, that combine different metals into tools superior to single material alternatives. Ottoman blades featured hard steel cutting edges with flexible iron spines, creating weapons that held sharp points while absorbing impact without breaking. Differential hardening produced tools with varying hardness across different areas through precise temperature control and timing. Surface treatments enhanced performance using only traditional materials, often making tools more effective than modern alternatives with synthetic coatings. Quality testing ensured consistent performance through systematic evaluation. Ottoman smiths tested flexibility through controlled bending, evaluated hardness with cutting tests, and assessed durability using stress applications that reveal potential failure points before tools reach users. Your gas forge runs out of propane and you're done. Ottoman blacksmiths created forging temperatures using any combustible material: wood scraps, charcoal, even dried animal waste. They understood heat management that allowed consistent high-temperature work regardless of fuel availability. Charcoal production was essential for maximum heat output. Ottoman smiths converted any wood into quality charcoal through controlled burning that maximized carbon content while eliminating impurities. Different wood species produced charcoal with specific characteristics suitable for different applications. Forge design optimized heat efficiency through systematic airflow management that maximized temperature while minimizing fuel consumption. Temperature control maintained consistent heat levels throughout extended sessions using fire management techniques that worked for hours without fluctuation. Heat conservation captured and reused thermal energy through workflow sequences that utilized residual heat for secondary operations. Multi-fuel capability allowed continuous operation using whatever combustibles were locally available, transitioning seamlessly between different materials. Watching modern smiths panic when their gas runs out while Ottoman masters forged quality tools using dried grass is pretty humbling. If you're realizing our advanced technology isn't as reliable as we thought, definitely subscribe because we're just getting started. Modern manufacturing uses expensive testing equipment. Ottoman blacksmiths achieved comparable results using traditional methods that worked anywhere, anytime. Visual inspection revealed metal structure and potential weaknesses. Acoustic testing identified internal flaws through sound patterns. Systematic stress testing simulated extreme conditions to identify failure points before tools reached combat. While European armies spent fortunes importing weapons, Ottoman forces generated equipment superiority through systematic recycling that turned enemy defeats into manufacturing resources. This wasn't just military efficiency, it was economic warfare that created sustainable advantages. Resource independence eliminated dependence on external suppliers or trade routes. Cost advantages were extraordinary because raw materials cost nothing beyond collection and processing. Quality superiority emerged from systematic material optimization that improved every piece of salvaged metal. Production scalability meant manufacturing capacity increased with military success because victories provided more materials. Strategic flexibility allowed rapid adaptation to changing requirements without lengthy procurement processes. Knowledge preservation maintained capabilities regardless of political disruptions. Today's supply disruptions and material shortages expose how vulnerable our systems have become. Ottoman smiths offer a different model based on knowledge, adaptability, and resource optimization that worked for centuries without external dependencies. Modern manufacturing depends on global supply chains that fail regularly. Ottoman techniques demonstrate how systematic recycling creates superior products using resources others consider worthless. Knowledge-based manufacturing depends on human expertise rather than technological complexity, offering resilience when systems fail. Personal applications include tool making and repair skills that provide independence from manufactured alternatives. Community resilience benefits from distributed manufacturing knowledge that creates local production capabilities. Economic opportunities exist for those who master traditional methods that create value from waste materials. The biggest insight is that advanced technology isn't always superior technology. Ottoman smiths achieved results modern manufacturing struggles to replicate using methods that worked reliably for centuries without external dependencies. Thanks for exploring metallurgy mastery that modern engineers are scrambling to understand. If these techniques impressed you, smash that subscribe button and hit notifications because we've got more traditional skills that shame our advanced technology. Drop a comment about which aspect amazed you most: portable workshops, scrap recycling, or the fact they never ran out of materials while we panic over shipping delays. Share this with anyone who thinks modern manufacturing is as good as it gets. Here's the reality check. Ottoman blacksmiths operated 400 years without supply problems. We can't go 4 months without shortages. Maybe they knew something about manufacturing we've forgotten in our rush to automate everything.